Hi everyone. Today we are looking at section 4.6, which is congruence in right triangles. You should have a warm-up on the very beginning of your notes. I would like for you to try that, and when I'm back in person, we will go over the answers to your warm-up. And this is your warm-up. This is from 4-5. And we will again go over these answers when I am back in person. So, today's lesson, again, is congruence in right triangles, and our lesson objective is I will be able to prove right triangles are congruent using the hypotenuse-leg theorem. So, first piece of information is the definition of a right triangle. It has one 90-degree angle. In a right triangle, the opposite of the right angle is called the hypotenuse. It is the longest side in the triangle. The other two sides are called the legs. So in this example, AC is our hypotenuse, and then AB and BC, that are the legs. And notice that the hypotenuse is directly across from the 90-degree angle. The hypotenuse-leg theorem, or we're going to call that the HL theorem, that states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So what does that mean? If we're looking at this diagram, notice I have a right triangle. We have two 90-degree angles. The hypotenuse are congruent. And then also we have an additional side here, PQ and XY, that are congruent. Because we know this information, pretty much what's really important is this 90-degree angle. Because we know this information, we can actually state that the two triangles are then congruent. So it's a really important theorem when it comes to 90-degree angles and right triangles. We can't use this theorem with other angles and triangles. Okay, so there are some conditions. There has to be two right triangles, obviously. I just said this doesn't work with any other type of triangle. The triangles have to have congruent hypotenuses. So what this means is if both of the legs in the right triangles were congruent, that might not be enough information for us to state that the triangles are congruent. And then lastly, there is one pair of congruent legs. Okay? So, on this example, you don't have the image on the left, but I think you do have this image here. And if not, draw this in your notes. It says on the basketball backboard's brackets, angles ADC and BDC are right angles, and we know that AC is congruent to BC. Are the triangles congruent, and can we explain? So, first piece that I'm going to do is just label everything. So I see that BDC is labeled as a 90-degree angle. I'm going to also label ADC. And then we know that AC and BC are congruent. Well, looking at this diagram, I notice that DC is congruent to itself. Okay. And this is our reflective property. And now, if you notice, I have the hypotenuse in both triangles. I have AC and BC. I have two 90-degree angles that are congruent. And now DC, because it's a reflective and it's congruent to itself, that's congruent, that's a leg, we do have enough information. So we can say, yes, triangle ADC is congruent to triangle BDC. There we go. In this next one, this is a proof. This is actually very similar to what we just got asked to do in the first problem. And I would actually recommend pausing this video and trying to see if you can do this proof on your own. It should only be a couple lines, but we're going to do it right now. So first step, always given angle PRS and angle RPQ are right angles. And then we know that SP is congruent to QR. And all of that is labeled in our diagram. So first thing, we have to state that because they are right angles, they are congruent. So we have to state that PRS is congruent to angle RPQ. And again, all right angles are congruent. So right now I have a side and I have an angle. We have, and the sides we have are the hypotenuses, so we have to find a leg. Well, if you notice, I have line PR in our diagram. It's in both triangles, so we can actually state that it's congruent to itself. So we're going to do that next. So PR is congruent to PR. Again, reflective property. And now I have a hypotenuse, a leg, and the 90-degree angle, okay? So because of that, we can go ahead and state that triangle PRS is congruent to triangle RPQ. And again, this is our new theorem. This is the hypotenuse leg theorem. And there we go. We just proved that they are congruent. Okay. Again, try to see if you can do this proof, but I am going to go ahead and do this one out. But I think you guys might be able to do it on your own. Now we're given a lot of information, okay? So first of all, we know that BE bisects AD at point C. We know that AB is perpendicular to BC. We know that DE is perpendicular to EC. And then we're told that AB is congruent to DE. Now, in the diagram, we have angle B and angle E marked as 90-degree angles here. But notice in the information that we're given over here, nothing is telling us they are right angles. So even though it's in the diagram, we actually have to use this information to actually conclude that they are 90-degree angles. So we are going to go ahead and state that angle B is a right angle. And we can state that angle E is a right angle, okay? And again, this has to do with this line here. This is the definition of a perpendicular bisector. That's what's making angle B and angle E right angles. Now that we know they are right angles, I can then go ahead and state they are congruent. So I can say that angle B is congruent to angle E, and again, all right angles are congruent. So now I have one side, and it's actually a leg, so BA and DE, those are legs. And then I also have the 90-degree angle. So I have to actually prove that the hypotenuses are congruent. So that's where this information comes in handy. Okay, BE is bisecting AD at point C. Okay, so because of that, we can actually state that AC is congruent to DC. And again, this is the definition of a bisector. And now that I have just proven that those two pieces are congruent, we can go ahead and state as our fifth statement that triangle ABC is congruent to triangle DEC. And again, we're using the hypotenuse leg theorem. And we are done. Okay. I believe this is the last one. Again, I would recommend pausing the video, seeing if you can get the answer. So, number 1, CD is congruent to EA. Already marked in the diagram. Good. And there are hypotenuse, which is really, really helpful. We also know that AD is the perpendicular bisector of CE. Okay, so this is given. So we have some information. We know that AD is the perpendicular bisector of CE. So first of all, because of it being a perpendicular bisector, we can state that angle ABE and angle CBD are right angles. And again, that's going to go back to our definition of a perpendicular bisector. And now that we know that they are right angles, again, we can state that ABE is congruent to angle CBD. Again, all right angles are congruent. And I'm going to denote that in our diagram. Okay, so we have the right angle and we have the hypotenuse. Now I just have to prove a leg. Well, again, we're going to go back to the fact that we have a bisector. AD is bisecting CE. So that tells me that CB is congruent to EB. And that would be the definition of a bisector. And now that I have my 90 degree angle, the hypotenuse, and a leg, we can finally then go ahead and state that CBD is congruent to triangle EBA. And lastly, that is the hypotenuse leg theorem. Okay. Only other thing that I need you guys to do for me is your 4.6 homework. The sub should have that. And that is about it for today. And I will see you all next time. Bye, everyone.